For centuries, humans have gazed into the night sky, wondering if we are truly alone. Now, new evidence from NASA may bring us closer to the answer than ever before. A distant world, Kepler-452b, shows signs that it could be something extraordinary. What if there's another Earth out there? What if someone is trying to contact us? Let's uncover the truth. Chapter 1. A mysterious signal from deep space. It started like so many discoveries do. Not with a thunderclap, but with a whisper. In early May, one of NASA's deep space observatories picked up an odd blip. A narrow, repeating signal buried in a wave of cosmic noise, coming from a region about 1,100 trillion kilometers away. That's over 100 light-years from Earth. At first, it was dismissed. These kinds of anomalies happen all the time. False readings caused by equipment glitches, passing asteroids, or even interference from satellites. But then, the signal came again, and again. It wasn't random. It had a structure, a pattern, something that didn't quite belong to the background hum of the universe. The source? A star system already familiar to astronomers. Kepler-452. Years ago, this system made headlines when NASA discovered a planet orbiting it, Kepler-452b, a rocky world located squarely in its star's habitable zone. Back then, it was labeled a second Earth. But the excitement faded. The data was intriguing, sure, but too vague, too limited to draw real conclusions. Now, Kepler-452 was back. And this time it wasn't just reflecting starlight, it was sending something out. NASA immediately launched a focused observation campaign, pulling in help from the European Space Agency, ground-based radio telescopes, and even the James Webb Space Telescope. They wanted to be sure. And what they found next pushed the mystery to an entirely new level. The signal appeared to originate near Kepler-452b itself. It wasn't just noise, it pulsed in a repeating rhythm, every 18 hours, like clockwork. But what truly shocked scientists wasn't the signal's timing, it was its composition. Within the electromagnetic signature were signs of oxygen, not just in the surrounding system, but likely in the atmosphere of Kepler-452b. Let that sink in. We are detecting the chemical fingerprint of one of life's most essential elements, on a planet more than 100 light-years away. Not only that, but the oxygen levels weren't static. They fluctuated, suggesting some kind of active cycle. On Earth, that cycle is called photosynthesis. Chapter 2. The Legacy of Kepler-452b. Long before this mysterious signal, Kepler-452b already held a legendary status among astronomers. Discovered back in 2015 by NASA's Kepler Space Telescope, it was the first Earth-sized exoplanet ever found orbiting within the habitable zone of a sun-like star. The media dubbed it Earth 2.0, and for good reason. It was located in just the right zone, not too hot, not too cold, where liquid water could exist. The planet was estimated to be about 60% larger than Earth, and it orbited its star in 385 days, almost the same as our own year. Kepler-452, the host star, is about 6 billion years old, which makes it roughly 1.5 billion years older than our Sun. That's important. It means Kepler-452b had more time. Time for evolution, for ecosystems to develop, maybe even for intelligent life to emerge. But back then, our tools were limited. We couldn't directly observe the planet's surface or atmosphere. We could only infer things from brightness dips and spectral shadows. Clever, yes, but imprecise. Over time, other discoveries overshadowed Kepler-452b. It became a footnote, a relic of an earlier chapter in exoplanet exploration. Until now. Because what the signal brought back into focus wasn't just an old planet. It was a renewed possibility that somewhere out there, a world like ours might not just exist, but might be alive. In hindsight, Kepler-452b was always an intriguing target. Its gravity is estimated to be about twice that of Earth's, which would make walking on it like carrying a heavy backpack all the time. Its surface could be rocky, mountainous, perhaps even volcanic. But if it had an atmosphere, and now we suspect it does, it might trap heat, regulate temperature, and support a stable climate. Scientists now believe that Kepler-452b may not be just Earth-like in orbit and size, it might be Earth-like in function. The fact that we're now picking up signatures of oxygen only deepens the mystery. Could photosynthesis be at work on this world, billions of years older than ours? And if it is, how far could life have come? Chapter 3. Oxygen in the Void. Oxygen. It's one of the most familiar elements to us. After all, we breathe it every moment of our lives. But in the vast cold vacuum of space, oxygen is rare. In fact, it's fragile. It doesn't like to exist on its own. It reacts, it bonds, it disappears unless something is constantly producing it. And that's what makes Kepler-452b's atmosphere so strange. When scientists analyzed the returning data from the James Webb Space Telescope and supporting observatories, they found something that didn't make sense: a clear, repeated spectral fingerprint of free oxygen in the upper atmosphere of the planet. Not bound in water or carbon dioxide, but as O2, molecular oxygen, just like what we have on Earth. Now, here's the twist. On Earth, the only known process that creates large amounts of free oxygen is life, specifically photosynthesis. Plants, algae, and cyanobacteria take in sunlight, water, and carbon dioxide and release oxygen as a byproduct. Without life, Earth's atmosphere would contain almost no oxygen at all. So when we see oxygen on another world, especially in unstable concentrations, it raises serious questions. Further analysis showed that oxygen levels on Kepler-452b rise and fall in a repeating seasonal pattern. Every few months, the concentration increases, then decreases, then rises again. This kind of cycle mirrors what we see on Earth, where plant growth and decay fluctuate with the seasons. But that's not all. There were also signs of methane, another molecule closely tied to biological activity. On Earth, methane is produced by everything from volcanoes to microbes. But here's the thing: methane and oxygen destroy each other. They react quickly, and if both are present in high amounts, it usually means they're being actively replenished. In other words, something might be maintaining this balance. Now let's be clear. Oxygen and methane can have non-biological sources too. Certain geological processes, like volcanic activity or UV radiation splitting water, can produce them. But the combination of oxygen, methane, and seasonal variation, that's a cocktail scientists are trained to watch very, very closely. We're not just talking about a planet in the right place, with the right size. We're talking about a planet showing the chemical signs of life itself, or at the very least, something that behaves exactly like it. And if that's true, then Kepler-452b may not be just a second Earth in theory. It might be a second Earth in practice. Chapter 4. The James Webb Connection. When the strange signal from Kepler-452b caught NASA's attention, there was only one tool powerful enough to investigate it in depth: the James Webb Space Telescope. Launched in 2021, Webb is the most advanced observatory humanity has ever put into space. With its massive gold-plated mirrors and infrared capabilities, it can peer into the atmospheres of distant exoplanets, reading the chemical signatures left behind by gases, particles, and even clouds. So when scientists pointed Webb toward Kepler-452b, they weren't just hoping for confirmation, they were looking for answers. And Webb delivered. Using its near-infrared spectrograph, NIRSpec, the telescope scanned starlight filtering through the atmosphere of Kepler-452b as the planet passed in front of its star. This method, called transit spectroscopy, lets astronomers detect which wavelengths are absorbed or altered by gases in the planet's atmosphere. The results? Startling. Webb not only confirmed the presence of oxygen, but it also picked up signs of carbon dioxide, water vapor, and trace amounts of methane, all layered in a dynamic, shifting atmosphere. Even more intriguing, Webb detected variability in those gases, not just static values, but subtle changes over time, suggesting a living, breathing system of circulation and renewal. In one particularly significant observation, Webb detected an infrared dip that may point to high-altitude clouds or haze, possibly water-based. While this isn't direct proof of oceans or rain, it's yet another hint that Kepler-452b might have a water cycle, a crucial ingredient for life as we know it. But perhaps the most puzzling finding was something missing. No signs of sulfur dioxide or other volcanic gases that might otherwise explain the oxygen or methane through geologic processes. In other words, there's no strong evidence that volcanoes or natural chemistry alone could account for what we're seeing. And that leaves only a few possibilities. Either Kepler-452b is home to an unknown geologic process we don't understand, or something more extraordinary is happening there. For now, scientists remain cautious. They've seen false positives before, but the Webb data is hard to ignore. It's clear, it's repeatable, and it matches what multiple observatories are now detecting independently. If these trends continue, Kepler-452b could become the most important exoplanet ever discovered. Not just because it resembles Earth, but because it might be living too. Chapter 5. Could life really exist there? So the big question is no longer, could life exist somewhere in the universe? It's now become, could life exist here? On Kepler-452b. Let's start with the basics. Kepler-452b is roughly 60% larger than Earth in diameter, which puts it in a category called a super-Earth. That means it's rocky, not gaseous like Jupiter, and has a solid surface. Based on its estimated mass and volume, scientists believe its gravity could be up to twice as strong as Earth's. That's significant. If you were to stand on its surface, every step would feel like carrying another version of yourself on your back. Movement would be harder. Climbing a hill might feel like climbing a mountain. But it's not unthinkable. Life, if it evolved there, would simply adapt to this pressure. Bones might be denser, muscles stronger, trees shorter and thicker. Flight, if it ever evolved, would be rare or entirely different. Now let's talk about temperature. Kepler-452b orbits a star very similar to our Sun, only slightly brighter and older. It completes one orbit in about 385 Earth days, meaning its year is eerily close to ours. Scientists estimate the planet's average temperature could be moderate, depending on the thickness of its atmosphere. If it has a stable greenhouse effect like Earth does, it might maintain a surface temperature that allows liquid water, and possibly even oceans. And remember, Webb picked up signs of water vapor. That alone is a game changer. Then there's atmospheric composition. The presence of oxygen, methane, and carbon dioxide suggests a potentially breathable environment, at least for microbial or plant life. For humans? Not quite. The planet's gravity, atmospheric pressure, and unknown toxins would make it lethal, at least without protection. But life doesn't have to look like us. On Earth, life thrives in extremes. Deep under the ocean near volcanic vents, in frozen Antarctic lakes, in acidic caves, in radioactive zones. If life exists on Kepler-452b, it might be microbial, like the earliest forms of life on Earth. Or it might be something completely alien, adapted to high pressure, low light, or even chemical energy sources we can barely imagine. There's also the age factor. Kepler-452b's star is about 1.5 billion years older than our Sun. If life formed there at the same pace as it did on Earth, then it's had more time. More time to evolve. More time to develop complexity. More time, perhaps, to develop intelligence. And that thought lingers. What if, somewhere under those thick clouds, life not only exists, but thinks, communicates, wonders, just like we do? Maybe that's what the signal is, not just a chemical anomaly, but a message. Chapter 6. What happens if we make contact? The idea of making contact with extraterrestrial life has fascinated humanity for decades. But what if that moment is closer than we think? If the mysterious signal from Kepler-452b turns out to be artificial, meaning it's not a natural phenomenon, but a deliberate transmission, it would change everything. First, NASA and the global scientific community would spring into action. Institutions like SETI, Search for Extraterrestrial Intelligence, would coordinate to verify the signal, trying to decode its content or pattern. Massive arrays of radio telescopes around the world would focus on that star system. Data sharing between nations would increase dramatically. The stakes, astronomically high. Governments might convene emergency meetings, while the media frenzy would be unstoppable. The public reaction would range from excitement and hope to fear and uncertainty. But beyond the hype, there are serious protocols in place. The post-detection protocols developed by the scientific community outline how to handle such events responsibly. Transparency and verification are key. Scientists would work meticulously to rule out false positives, hoaxes, or natural causes before any announcement. If the signal includes complex patterns, like prime numbers, mathematical sequences, or coded information, it would be a strong indication of intelligence. Then comes the question: do we respond? Some argue for caution. Sending messages back could reveal Earth's location to unknown civilizations. Others believe communication is essential for understanding and growth. Regardless, the discovery of even a simple, repeating signal would be one of humanity's greatest milestones. It would force us to rethink our place in the cosmos. Philosophers, theologians, and everyday people would grapple with new questions about identity, purpose, and coexistence. Would humanity unite or fracture? Would our technologies advance faster? Would space exploration accelerate? No one knows for sure, but one thing is certain: if Kepler-452b is sending us a message, the universe just got a whole lot bigger. If these trends continue, Kepler-452b could become the most important exoplanet ever discovered, not just because it resembles Earth, but because it might be living too. Chapter 7. What this means for Earth. Discovering signs of life, or even intelligence, on Kepler-452b would be a momentous shift for humanity. It would no longer be a question of, are we alone, but what does it mean to be alive? Such a discovery would challenge centuries of scientific, philosophical, and cultural beliefs. Religions might reinterpret creation stories. Science would face new frontiers, redefining biology, evolution, and the very definition of life. On a practical level, this finding would spark a surge in funding and interest in space exploration. Governments and private companies would race to develop new telescopes, probes, and perhaps, one day, interstellar missions. Educational systems worldwide would adapt, teaching new curricula focused on exoplanetary science and astrobiology. Young minds would grow up inspired by the knowledge that life exists beyond Earth. But there would also be challenges. The realization that Earth is not unique could provoke existential anxieties. How would humanity cope with the knowledge of another world harboring life, possibly more advanced? The environmental movement might gain strength as Earth's fragility and uniqueness are better understood. The pale blue dot concept, popularized by Carl Sagan, would resonate deeper than ever. Moreover, international collaboration might improve. Facing the vastness of the cosmos and shared destiny could unite disparate nations in pursuit of common goals. In short, Kepler-452b isn't just another planet. It's a mirror, reflecting humanity's hopes, fears, and endless curiosity. The discovery forces us to ask, what kind of life do we want to be? How do we protect our planet while reaching for the stars? Chapter 8. The Big Unknowns. Despite all the excitement, many mysteries remain. We don't yet know the exact nature of the signal. Is it truly artificial? Could it be a natural phenomenon we simply don't understand? The composition of Kepler-452b's atmosphere raises questions. How stable is it over longer timescales? Are oxygen and methane being replenished continuously, or is this a temporary anomaly? We also don't know if any life forms, microbial or intelligent, exist there, or if the signals are just echoes of past activity. Future missions and telescopes will try to answer these questions. The James Webb Space Telescope's successors, ground-based observatories, and possibly interstellar probes will play crucial roles. Until then, all we can do is watch, listen, and hope. This discovery reminds us that the universe is far more complex and fascinating than we ever imagined. Kepler-452b might be a second Earth, or it might be a first step towards understanding life beyond our blue planet. Whatever the truth, one thing is certain: the search is only just beginning. Whether Kepler-452b holds life, or just the potential for it, it reminds us of one powerful truth: we are only just beginning to understand the universe. The more we explore, the more we realize how small and how connected we truly are. Thank you for watching. If you want to keep discovering the mysteries of space, subscribe and join us on this cosmic journey, because the search is only just beginning.